Okay, go for it.
Thanks, ladies and gentlemen, and welcome to, I think, is this the 15th webinar in our series, Edison, on electrically powered aircraft. We've got a great crew for you today with representatives from several companies. I think it'll be an interesting show. Today, we'll have an opportunity to hear really the perspectives from firsthand people who are doing disruptive technologies in the industry right now. You'll have a chance to ask questions of our panel, and we'll leave plenty of time for Q&A today and promote discussion about really where things are going in the future of aviation, where the future of electronic technology and hybrid technologies are, challenges and opportunities. So without further ado, I'd like to introduce today's panel. We'll start with Roei Ganzarski, who is CEO of magniX, based out in Seattle. And as you may know, they've powered some modified de Havilland Beavers in air taxi service out in Vancouver, BC. So they've got some interesting experience there. Roei is originally from Israel, moved to the US in '97. He's worked with magniX, obviously, Bold IQ, and Boeing. Interesting in his household, there's a wife, 3 kids, 2 dogs, 3 goats, a couple of chickens, and he's ready to hunker down during whatever happens with COVID. So thanks for joining us, Roei. Our second panelist is Tine Tomažič, who has a PhD in electric hybrid powertrains for aviation. He's been working on a number of projects. I've got to minimize the picture on my screen. Led or participated in the development of 9 electric aircraft powered by batteries, ICE generator hybrid, and hydrogen fuel cell battery hybrid powertrains. So a variety of options there, and that'll be interesting from a technology perspective to learn from him today. Currently focused on zero-emission eVTOL for cargo and taxi missions, as well as a commuter-sized hydrogen-powered mini-liner. Pipistrel also has the first certified electric aircraft, which obtained EASA certification earlier this year. So I'm sure we'll talk about that as well. And last but not least, from ZeroAvia is Katya Akunacheva. Katya has an impressive background from Oxford and INSEAD, also in finance and venture capital. She joined ZeroAvia to run investor relations in their UK operations. And she previously ran a VCR of a sustainable consulting and investing firm. And she led the investment there in ZeroAvia, so she knows it both as an investor and an employee. So I'm sure she'll have some interesting things to talk about with their technology as well. So without further ado, I'd like to get started, and we'll start with Roei. Roei, can you tell us a little bit about magniX and what you folks are doing and your view on the future of electric aviation?
Sure. First of all, I find it fascinating that all 3 of us in electric, or I'll call it alternative aviation, have complicated last names. I don't know if that's like a requirement to be in this industry, but it seems to follow. Thank you for having me. Electric aviation is a phenomenal thing that's happening, and we are lucky enough to be in the midst of it when history is changing. I will keep my introduction very short because I'd rather have a longer time for back and forth, because I think that's what makes it interesting. So magniX, you can look online, www.magnix.aero, to see who we are. We're an electric propulsion company. We basically build the motor, inverter, power electronics that sit in front of, behind of, or on the sides of commuter size and above electric aircraft. The smallest aircraft we work on will be 5 passengers and above, so we don't do anything smaller. We look at what Pipistrel does with phenomenal admiration. They are leading the way and doing a great job where it comes to getting things certified and moving things forward. As mentioned, our first project or first flying platform is the eBeaver, a de Havilland Dash 2 Beaver that we converted, or what we call magnified, to all electric, together with Harbor Air, the second largest seaplane airline in the world, up in Vancouver, British Columbia. That plane is flying around in Vancouver, and we're getting ready to, or in the midst of the process of certifying that aircraft/propulsion system. That started back in December 2019 and continues to fly ever since. In May, we went even larger to a 9-passenger Cessna Grand Caravan, which we magnified, and that continues to fly here in eastern Washington State in Moses Lake. That aircraft, we also took to 8,000 feet, checked elements like Corona, not the Corona we're used to, but the other Corona that has to do with electric boxes. So did some testing around that. And then we're working on different platforms as well. The last thing I'll say is that as a propulsion company, we are not limited to or focused on any specific type of aircraft or propulsion or electricity, meaning we work with batteries of all sorts. We work with hydrogen fuel cells of all sorts. We even work with internal combustion generators of all sorts. As long as we get electrons and the electric propulsion system is what turns the propeller, we consider that an electric aircraft. And with that, I'll end.
Thank you. Tine, let's turn it over to you and tell us a little bit about Pipistrel and your certified electric aircraft and other research.
Thank you. Pipistrel has been flying electrically since 2007, long before it was cool. By the time it got cool in mid-2016, we already flew 5 types, so we're up to 9 at the moment. And our recent endeavor with the type certification is essentially considered as a creation of an ecosystem also for other people to follow. So we are eager to see what things we have enabled, because one probably doesn't realize that a type certificate on the aircraft alone does not unlock operations with electric aircraft. So one has to figure out pilot licensing, charging, airport operations, safety, first responders, a lot of things. The aircraft that is type certified is battery powered, but we have been busy with hybrids before, and we are busy still as part of research. So in the continuation of 2020, we will fly 2 different hybrids, one based on hydrogen fuel cell, pressurized hydrogen storage technology, the other one employing an internal combustion engine as the generator for the electric flight. But both are powered by an electric motor, and we are aspiring also for larger applications so that hopefully we can employ some magniX elements as well. Our direction goes into 2 fundamental paths. One is a mini liner, which is a commuter-sized, hydrogen-powered, complete zero-emission airplane, capable of doing multiple hops per day in regional distances. The other direction is, of course, eVTOL. Both of these project directions rest upon distributed propulsion as the enabler. And as a policy in the company, we are basically done with retrofitting existing airframes with novel propulsions, and we are only focusing on entirely new designs from scratch, which are the way they are and do things they do because they are electrified and don't happen to be electrified because we slammed a different propulsion means them. This is for us something that brought us to where we are today, but we believe strongly that it's only the marriage of the airframe as well as the propulsion system that yields the appropriate results for much better comfort in flight, much lower noise, and also a significant drop in operating cost. It used to be the case that an aircraft is built around a propulsion system or an engine. Right now, I think the mantra should be the aeroplane has to be built from scratch together, to work together and yield the synergistic effects with the propulsion system and not be built around it.
Thank you, Tine. Katya, your turn.
Thanks. Hi, everyone. Thanks for having me. So I'm from ZeroAvia. So ZeroAvia is a hydrogen electric powertrain company, and we're initially focusing on the 19-seater sort of sub-regional segment, but really hoping to pave the way for hydrogen in aviation at scale. We're just under 3 years old, so we were set up in late 2017 by our founder, Val Miftikov, who comes from the electric vehicle space previously. So he's very familiar with batteries and electrification of transport in general. But in aviation in particular, we decided that hydrogen was the most promising technology, and that's really what we focus on. And it's been interesting, I think, for us over the last 3 years to watch hydrogen rise to greater and greater prominence more broadly globally in the role it has to play in energy transition. So it's been really exciting to watch that momentum building. At the moment, so we're still kind of relatively early stages. We're working on a 6-seat prototype. So we recently flew a Piper Malibu in the UK that was initially actually flown on battery, and our next flight will be done on hybrid hydrogen battery, and moving to hydrogen only. We will not be commercializing our powertrain for that size aircraft. Our first commercial product will be targeting the 19-seat aircraft. We are currently considering a number of potential platforms that we would focus sort of that offering for, but ultimately we hope to work with a number of different already certified airframe platforms and just create the powertrain component. And I guess just to mention some of the themes that others picked up on, I think it's great to see that Pipistrel is leading the way in regulation, because certification rather, certainly that is one of the biggest bottlenecks that we've encountered so far. I think while there are absolutely challenges and hurdles to overcome on the technical side, we think that kind of we can actually see the roadmap quite clearly, and its certification and infrastructure rollout that will be the kind of biggest hurdles for us to overcome in the coming sort of years and decades to really see this grow at scale. So yes, that'd be a quick intro, and looking forward to the questions.
Thank you, Katya. In terms of looking at electric aviation, clearly there are a number of benefits from the environmental side to operating economics, and certainly the environmental benefits are critical as we look forward with our era of climate change and climate change mitigation. Where do you see the benefits of electric aviation? Roei, why don't we start with you and go with each of you again on that issue?
Sure. I'm sure that Pipistrel and ZeroAvia would agree. None of us are Greenpeace. We're not here to save the world. We're here to enable a better technology that allows operators to fly at lower operating costs while completely being clean. I think aviation industry has proven that if you only focus on environmental, you'll fail. SAF, synthetic fuels, are a perfect example of that. It's available and can be used to reduce emissions, but it's 3 to 7 times more expensive than regular fuel. And lo and behold, no one's adopting it. Very few are actually using it, and they're doing it more for PR than anything else. And so the environment, while we would all like to say is key and important, no one's willing to actually spend extra money on it. The beauty of electric, be it battery, hybrid, hydrogen fuel cell, etc., the beauty of electric is it actually reduces operating costs. To give you an anecdotal or actual data-driven example, the Cessna Caravan that we've been flying, which is again 9-passenger aircraft, for about a 1.5-hour flight, you'll be spending $24 in electricity as opposed to $404 in fuel. That's just direct power cost. 24 versus 404, split that amongst 9 passengers, and you can see the difference in operating costs, given everything else is equal. Now add to the fact that electric motors need a lot less maintenance than their internal combustion engine brothers do. There's no overhauls, there's no oil changes, et cetera, et cetera. The reliability of the motor is longer. The lifetime of the motor is longer. And so the operating costs, we estimate right now from what we're seeing on the 2 flying platforms, are anywhere between 40 to 80% lower per flight hour, depending on where you're starting. 40 to 80% lower. That means that operators can take on more planes, take on more flights, take more passengers, go from smaller airport to smaller airport, so provide better services, maybe even as close to an on-demand service for the middle class that you can imagine, and do it all without creating any emissions. So from that perspective, the real advantage of electric and its electric offshoots is the fact that it's lower operating costs, while a very good side benefit is the fact that there's 0 emissions.
Thanks. Tine, your thoughts on that topic?
I would like to build on top of Roei, actually. Yes, we are seeing also in our trainers that we deliver to the customers, electric ones, basically a 70% drop in total operating cost. And this is also when you do consider the battery replacement cost, because one thing is the direct cost of electricity you use, but for every battery cycle, a part of the battery dies away. So you have to consider that. But even with that, 70% based off average, it's amazing. And I think it is a key fact that will make or break the adoption of electric flight. It's a fact. So environment is nice, but it's the affordability that will drive the adoption. So having said that on battery, this is, I think, where hydrogen has the edge. So not as much of the powertrain system dies away with every flight when you're considering hydrogen. So in the long run, the operating cost savings or the economics potential is even larger there. So that's why we continue to spend our efforts and development time there as well. But what I would like to focus on is also the non-trivial things. And they are connected to the simplicity of operation, you know, how the pilot or the operator manages the whole powertrain. There's far less buttons, far less things to look at, both in the operation as well as maintenance, and lower noise when the aircraft developer, the OEM, does the job correctly. Meaning that entirely new missions can start appearing, bringing new ways that people utilize aircraft for, either passenger carrying service from small airports to small airports. This is kind of what our mini-liner concept is discussing, without, excuse the word, pissing off the communities. If you annoy the communities, they will not let you in. And even if you have the fantastic product, which is cheap to operate, you will not be welcome. And on top of that, if you have an aeroplane which does not annoy the communities or basically the surroundings where it comes and goes to, the utilization rate all of a sudden goes up. So during the day, you may use the same airframe to carry packs, and you can repurpose it during the night because it does not annoy the communities to do something else, like overnight cargo deliveries and this and that. So it will take some smart moves and possibly also controversial moves by aircraft developers to position aircraft to do more than one thing, like combi missions and this and that, just because they can. And it is essentially not only defying the economics from the perspective of the flight itself is cheaper because of this and this and that, but the utilization of the aircraft is higher. And everybody, I think, should agree that the most expensive is the airplane that does not fly, that's on the ground. So electrifying aircraft, because of the potential of lowering noise and elevating the simplicity of flight, has the potential to significantly lift or increase the utilization rates, thereby driving the cost down even more significantly for the operators. So besides the clean, the more affordable electric flight will bring new ways of how aircraft are utilized and new missions and routes that these aircraft will take people or cargo on.
Katya, can you add to?
At this point, it's difficult to go last after those two, but I mean, absolutely agree with everything that everyone said. We, also really fundamentally believe the economics is what will drive adoption. So while the green credentials are important, that if they don't make sense economically, then it won't work at scale. So we equally are targeting a significant reduction in operating costs, again driven both by fuel cost savings as well as significant savings in O&M costs. We, as Tine mentioned, we do believe that hydrogen has a particular advantage, certainly for larger aircraft, longer missions. So that's why we're focusing on hydrogen. I mean, I would say that, we are only as green as the hydrogen is green. So while our business is not production of hydrogen, we do quite a lot of ecosystem engagement on that side as well, because we believe it's important to demonstrate that this can actually be zero emission end to end today, that it's not just sort of a future claim, that it may one day happen. So for example, I'm right now sitting at Cranfield University, which is where our test facility is in the UK, and we've actually here purchased a small scale green hydrogen production unit so that we can actually already now demonstrate that we can produce it on site using renewable electricity. We can recharge it ourselves from our own refueling truck, and we can fly completely green already now. So while it's not the driver for adoption, we do still think it's important to demonstrate that how it works and that it is feasible, and that we believe that green hydrogen will become more and more available over time. And it is a big part of our narrative. And the other just thing I guess that I wanted to pick up on is the point around sort of unlocking smaller airports and increasing the volume of maybe smaller aircraft travel. That's also a big part of our story. So we think that by making 20 to 40 seat aircraft cleaner, quieter, more economically viable than they are today, there's a huge opportunity to just ultimately change the way we travel. So if you have to travel for an hour flight rather than going to Heathrow, queuing for 4 hours and then taking a very short flight, we really think there's an opportunity to use small airports that are currently completely under capacity and to use small planes to connect people better. So I think that's also a really big part of our vision of how the world will change with electric aircraft. That's driven by environmental considerations, but ultimately is not the reason that it will shift that way. So
just if I may add to that, I think Katya and Tine put some phenomenal points forward. We can see now with COVID-19 and what's happening, how quickly airlines are willing to and able to pull out of medium, not even small, but even medium-sized airports, let alone the small and even smaller airports. So communities definitely across the US, but worldwide, are losing their connectivity. And while we would like to think that this will come back once COVID goes away, I remember when food was taken away from airlines when fuel costs were up and baggage started to get charged when fuel prices went up. And the story was, once fuel prices go down, all these surcharges and the service will come back. No, it didn't. Fuel prices went back down. We're still paying for baggage on airlines and we still don't get any food. And so once airlines pull out of these middle and small airports that aren't very profitable, they're going to learn a good lesson, which is, hey, I can make more money serving less people. So I'm going to do that. That's the beauty of capitalist economy, if you will. And the reason is it's so expensive to operate these planes and the infrastructure that's required. That's why I'm completely on board, and magniX is, together with Aviation and what ZeroAvia and Pipistrel are talking about. It's going to be about the middle-sized aircraft, not the 737 replacement or A320 replacement, but it'll be the replacement of everything from the de Havillands and Cessna Caravans all the way up to the ATRs, of those aircraft with significantly lower operating costs that create this new way of travel, which is, I don't want to go to Heathrow Airport 2 hours ahead of my flight, stand in line with thousands of other people getting COVID or not getting COVID, forget the hassle, only to fly 45 minutes to another airport that I have to then drive 45 minutes into town. Why not go to a small airfield next to me with 9, 10, 20, 30 other people, get on a plane and land at an airport that's closer by? Imagine what that does to how we define a suburb today. People are willing to drive an hour to an hour, have to work every morning in cities like LA or New York. Why not fly 20 minutes? And so what electric really does is allow you to change the way you think about flying, not just the operating cost for the airlines. On a second point that Katya mentioned about green hydrogen, we get a lot of, I'm sure we all do, naysayers who like to say, oh, it really isn't clean, even though the electric plane is clean, the electricity that was created, you produce CO2. That's an interesting argument. No one is quick to point out that the production of fuel creates even more emissions. But we did an exercise on that as well. And it seems that even when you take into account the value chain of the creation of electricity versus the creation of fuel, still an electric aircraft comes out significantly cleaner. That's one. And two, to Katya's point, not only is hydrogen a green possibility in terms of the production of it, so is electricity. There are multiple states and multiple countries now that more than 50% of power is produced by renewable energy. And that's only getting better versus the creation of fuel remains its same dirty self as it's always been.
Quick question for, I want to bring up something. Roei, when we first met maybe a year or two ago at an air show, we spoke about the Beaver and the whole issue of weight. And you pointed out to me with the Beaver, if you take out the fuel tanks and the weight that would have been in fuel, that you're going to use that now for batteries. Now, okay, fine. When the airplane is flying, you are burning up weight as the airplane flies. And with batteries, of course, you don't burn up weight. So what is the situation to the three of you? And I suppose we can start in the same order again. When do we see batteries capable of holding as much energy as, let's say, the equivalent weight in a fossil fuel?
How about we let Katya go first?
Thank you. Yeah. Well, I mean, I think in our choice of hydrogen sort of lies part of the answer, I guess, to the question from our side, which is that we think batteries will struggle certainly for larger aircraft for longer missions. So we think for eVTOL, for kind of 9, maybe 20-seat applications for shorter flights, batteries are a viable option, and they will continue to improve, you know, at accelerated rates on the performance side and on the cost side. But we believe that for longer missions and anything really more than 20-seat aircraft, which is where the bulk of aviation is today, we think that batteries just simply won't get there in time. And that's why we're working on hydrogen, because we think that hydrogen is a more promising option when you're looking at that sort of scale, that sort of range and you know, bigger passenger loads and things like that. We think the batteries can be a supporting technology for eVTOL. They're important, in particular for the high power sort of takeoff landing portions of the journey, but we think that they will struggle to accelerate in time, in the amount of time that we have to kind of solve this problem. So,
Tine?
Yeah, I was afraid you were going to ask me for an opinion as well. The batteries will never have the energy or power density of fuel. That's a fact, which does not make them useless. The beauty of distributed propulsion systems, so that you can have multiple power sources, as well as multiple power delivery means, like multiple motors scattered across your design, also allows the aircraft OEM to adjust or optimize the aircraft to what it needs to do. So it does that thing much better. And while in the past, there used to be only a handful of engine choices that an aircraft OEM could build the aeroplane around, so the aircraft were similar. I mean, there's a reason why 737 and an A320 are similar, and it doesn't have to do only with what the airlines want. It has largely to do with engine choices and other things. And there's certain segments of aircraft that have come to be. There will be much more diversity. So for different missions, you will actually fly different aircraft. Or maybe the same aircraft with a different energy source. It could have a load of batteries to be super cheap and having interesting turnaround times where the hydrogen refueling situation or infrastructure may not make an economic case. So it could be too expensive to put hydrogen powered stations everywhere. So let's say for thin routes, electric power is fine. And for most of these thin routes, you do not fly thousands of miles. On the other hand, there is just a few weeks old of a study by Bauhaus Luftfahrt from Germany, who architectured a hydrogen-powered aircraft, not fuel cell-based, but basically combustion of hydrogen, that goes London to Sydney. And it's a 200 pax aeroplane. So sizing-wise, yes, it can be done. And the future will then show into which direction the technology will mature into. You know, especially on the fuel cells, not too many people have paid attention to that in the world of aeroplanes, at least for the atmospheric applications. Space is a different story. So there is still a lot of potential for maturity and performance enhancements, and we are of course eager to what Katya and team and the rest who are striving to perfect them will come up with, so that we can build the aeroplane with them, not around them.
Katya, can you hurry up, please?
Yeah.
Working on it.
I'll just add a point, which is that we should all stop asking the wrong question. And there's a fallacy in asking, will batteries be as good as fuel? Show me the aircraft that flies on its full fuel potential. 737 and A320 are built to fly over 3,000 miles. It's a fact that 70% of them fly less than 1,000 miles. 50% of them fly less than 500 miles. So who cares that it can fly 3,000? The Cessna Grand Caravan has a range of 1,000 miles on a full tank of gas, but with only one person on board. Who cares? Who flies in an uncompressed aircraft with no toilet for 1,000 miles? I don't know that I can. And so the real question is, what's the range that operators and consumers want? And if you look at it, again, data shows that 50% of people fly less than 500 miles in range. That means that batteries today, with a well-designed aircraft, can do that. The aviation analysts will be able to do that. If you look at facts of where people want to fly, it's not to the major hub airports, it's to the small airports near their homes or offices. And so the question really is, are batteries or hydrogen fuel cells or hybrids good enough to fly what people want? And the answer is yes. Will you get the quick turnaround that you get today with fuel? No, but we have to remember, one of the reasons for the quick turnaround requirement is that it's so expensive to operate these planes. Every minute on the ground is so expensive, they want to turn it like crazy. But if the plane is, take Tine's number, 70% cheaper to operate, then maybe waiting another 20 minutes or 30 minutes on the ground isn't that terrible. Provide a better service to your customers, give them a cup of coffee, et cetera. And so we're going to be, again, thinking differently about aviation and even asking questions differently.
I agree.
Fascinating.
If we can we'll have one more question, and then we'll open it up to Q&A from the audience. So if the audience wants to submit questions on the chat function during the process, please do, and we'll open it up after the next round of questions for the panel. The next one is basically the timeline. We're in 2020. Where do you think things will be in 2025 and 2030, and when can we expect these technologies to mature?
Katya?
I can start. So we're, the timeline we're working on is our first commercial product that's targeting a sort of 20-seat aircraft should hopefully be certified in 2024 type of time. So that's when we're planning commercial introduction. So by 2025, we should hopefully be flying with a number of operators in a number of airframe platforms, and kind of rolling out at scale. And certainly by 2030, we would hope to have our next 1 or 2 commercial products developed that are be targeting larger airframes. So from the 20 or so seat aircraft, we will move to a larger turboprop in the order of sort of 50 to 80 seats. That will be our next big project. And thereafter, we will try to kind of sketch the pathway to get to larger aircraft. And by 2030, I think we will have probably a larger turboprop flying, but probably not yet the kind of bigger jet fully up and running. But we will hope to have like the real pathway for that sketched out and be actively working on its development. So yeah, and then I think, and the kind of parallel advances on the fuel cell, the hydrogen production, et cetera, side will need to happen for that to be the case.
Roei?
Right.
Or Tine?
I would just concur with Katya. I think the first wave of applications will be in the 24-25 arena. This may be aircraft that are re-engined with a few notable exceptions like the aviation and people who are quite far along in their designs already, so the shooting stars. And then the second wave, which where you may start to see tailored designs coming up, is in the 28 to 30 timeframe. And let's say 2030 being the more widespread commercial adoption of middle-sized airplanes, let's say 20 to 40s. The sizes of the aircraft actually isn't such an important parameter when you discuss distribution of the powertrain. So, I mean, if you take a 20-seater, you could use 10 of the propulsion units or 10 magniX motors. If you need a 40-seater, you take 5 more. I'm just spitting out numbers. So you don't have to re-engineer totally different components just to bump up the size of the aircraft. You are playing with combinatorics in the way you could not play before. So smart people may even have competitive designs in the same house, like various size airframes, utilizing the exact same components in the powertrains, just arranged differently, and maybe utilizing more or less of a certain, more or fewer of a certain component.
Yeah, I'll add to that in terms of time frame. So first of all, thanks to Pipistrel, the time is now. Right? People can start flying electric planes now. That's 2 years ago, who would have imagined that? If you would have said by 2020 electric planes will be flying, people would have said you're crazy. People today are still saying it's crazy, and yet here we are. Pipistrel's already flying electric aircraft. Certified. And so from that perspective, I think people have to come to grips with the reality that the world of aviation is changing. For us, our propulsion systems, the magniX 250 and 500, so both sizes, we expect to get certified under Part 33 last quarter of 2021, first quarter 2022, so kind of in that time frame, depending on things happen with COVID and the time the FAA can respond, et cetera. But around that time frame, which means that any of either modified or magnified aircraft like the Beaver or the Caravan, or a new aircraft like the Aviation could already get certified right after that. And so we expect that in 2022, we're going to see some magnified aircraft flying, meaning retrofits. By 2023, new aircraft designs flying our electric propulsion systems we'll expect to see. To your question on what happens by 2025, I think we'll see hundreds, not thousands, but hundreds of commuter lines being flown all electric. Electric being either hydrogen, battery, again, et cetera, but all electric, not hybrid. And by 2030, I think we'll see a majority of under 200-mile flights, even if not under 500 miles, being done all electric.
So major changes to the regional market.
I think so, and I think COVID-19 has, if anything, has accelerated that. We're already seeing, just this week in the news, or in the last week, United disengaged itself from one of its major supply subsidiaries, Express, that used to fly mid-sized turboprops and jets to fill up the larger aircraft, and it just disengaged from them because they're seeing that they won't be able to afford these things anymore. So I think to Tina's point about seeing different types of aircraft fly different types of routes, I think we're going to see a resurgence or a democratization, if you will, of operators. You're going to see, I think, major hub and spoke operators like a United, a British Airways, et cetera, flying large aircraft in trunk routes, London, Paris, right? Or London, New York, LA. You're not going to have a 9-passenger plane do New York, LA 1,000 times a day when you can have 5 aircraft being filled on those types of routes. There's really no need for it in the short term, I'm talking. But how many people actually want to fly LA, San Francisco versus they're actually flying Bakersfield to San Jose? And places like that, I think we're going to see new types of operators pop up that say, if I can now afford this type of electric aircraft and afford to operate it, I can open services that up until now we've only dreamed of. On demand, sharing, things that today exist for the 1 percentile of the world, right? If you can afford NetJets or ExoJet or flight options, et cetera, if you can afford that, let alone your own aircraft, then you're used to on-demand aviation. But for, I'm going to guess, the bulk of us on the call here, we fly when the airlines tell us they're willing to fly us at their schedule from the airport they want to fly at the time that they want to fly at the cost they're going to charge us, and we have no choice. And so I think that part's going to change. You're going to see more aircraft sharing, more on-demand schedule flexibility, more demand-driven aviation than you've ever seen before.
Thank you, Roy. Edison, do you want to start the Q&A?
Sure. Okay, the first question is hydrogen production economical in the anticipated volumes necessary? Can an aircraft carry enough hydrogen for the range? I suppose that would be a Katya. That's like right in your wheelhouse.
Absolutely. Yeah, so I think the analysis we've run shows that kind of a renewable electrolysis unit is profitable at 4 or more flights a day. So you can have a very small scale on-site hydrogen production facility at an airport with the associated refueling infrastructure that will be that will produce hydrogen at a price that is cost competitive with jet fuel. At 4 flights is the sort of number that we're looking at. So that's quite low volume. So anything more than that, if you look at an average regional airport, they will have quite a few more flights than that. Both the owner of the hydrogen infrastructure, production infrastructure, makes money, and the hydrogen itself is at a cost that makes it quite attractive compared to jet fuel, which would have been the alternative. So we think that the economics there actually look quite attractive. And in terms of can it carry the right amount of for the range, I mean, clearly that's a big question that we're working on. So hydrogen, at the moment, we're compressing it to 350 bar pressure. Over time, we will compress it more to 700, and longer term, we will be working also on liquid hydrogen. There's obviously a trade-off there between the weight of the tanks themselves and how that stacks up with, the more compressed it is, the more it weighs, and what that does for the kind of energy density. So it is an equation that we're kind of constantly playing around with. But in some cases, we may launch sort of city pair operations with only one set of refueling infrastructure. So we would then want to carry enough hydrogen to go there and back. Whereas in other cases, the route structure might warrant having a refueling infrastructure in both spaces. So we think it definitely can carry it for the right range, but there are a number of kind of modifications that we still continue to work on to get that right. Well, I think what we will likely have is maybe a set of 3 launch airport locations where 2 of them have refueling infrastructure, and their routes will be planned in such a way that you can sort of optimize it that way. But that's clearly a big task for us in thinking through a commercial rollout, is also figuring out the exact route structure that we want to target in the near term.
All right, next question to the panel. Can you discuss electric aircraft performance in cold weather regions? What needs to be done to achieve optimum battery performance?
Yeah, sorry, go ahead, Tine.
Unless you have something specific, I think people should really stop confusing the temperature in the surrounding of the aircraft and temperature of where the battery is. Just like we don't have people freezing in the cabins, we can make sure that batteries are not too cold wherever they are. In our case, they are liquid cooled and they operate at the exact same temperature in Abu Dhabi or somewhere up northern Canada. So it's not an issue. It's just an engineering task that has been solved before.
All right. Next question. Is electric aircraft operating costs competitive, even considering current battery lives and costs? Which are the figures of life and costs considered for the 70%-ish COC reduction?
Short answer is yes, and this considers battery cycle life and its replacement cost.
Okay, good. Next question. The start of great points, Roei. So I guess this is going to go to you. The same analogy from electric cars. We need to put people into these systems that they learn the advantages rather than aiming for the challenges. I suppose not really a question, it's really an endorsement of the vision that you shared, which is kind of, it moves everybody's cheese, I guess. Another question then. Can you all comment on alternative propulsion technologies besides propellers? That's an interesting one.
Yeah, so just like with the advent of the jet engine back in the day that brought in alternate, well, if you think of it, it's a series of propellers inside the jet engine, right? Just used very differently. That will happen with electric as well. Right now, given today's, and I'll start with something that was mentioned before, but aircraft design always follows propulsion. There's a reason today's age of aviation is called the jet age of aviation. It's not called the long range age of aviation or the swept wing age of aviation. It's called the jet age because of the jet engine. And so propulsion drives aircraft design. And so just like Tina mentioned before, propulsion also drives what types of various aircraft designs you'll see, not just the advances you'll get from them. And so from that perspective right now, given the technology that exists from a cost perspective and an applicability perspective, propellers are the easiest way to start this revolution. We could say, hey, let's develop something way more advanced, way more powerful, and it'll take another 10 years to start. Or what we're taking, the approach that I think all of us are taking, is the practical, what can we do to start this revolution now and get people used to it, right? Tesla didn't start with a 5-passenger SUV. They started with a 2-passenger car that could go 80 miles barely. And 8 years later, we're now at a truck. And so from that perspective, we're starting with propellers. It'll be very quickly going through enclosed propellers, replacement for jet engines, and then who knows what else, right? I think the real future is going to be some sort of propulsion system that doesn't rely on any moving parts. And that'll be something that none of us can even think of at this stage, but is probably coming very soon.
Okay, next question. Can you elaborate on the value creation by various bricks of the value chain? Who would like to take a crack at that?
Value creation of various bricks in the value chain.
Everybody must operate at a certain notional marginality to make a living.
Maybe just something to add on that one is if you look at, well, the future planned business model of Nikola trucks, they're not yet operating, but they are selling sort of kind of truck as a service, including fuel. So I think they've taken the view that on the hydrogen side of things, there is enough money to be made in the hydrogen production side, and there's significant enough economies of scale of kind of centralizing that it's an interesting business for them to integrate into their model rather than them just doing the truck side and having someone else doing the fuel side. So that's how they've chosen to offer their product to their customers, and it may well be that, you know, over time, at least we at ZeroAvia would consider doing the same thing. So integrating the fuel piece into what it is that we actually sell to operators. So in that case, the value chain might indeed become compressed across sort of the fuel side, parts of maintenance, and the kind of actual operation. And I say, so I think it'll be interesting to see how maybe the structure of the industry changes with some of these new propulsion and sort of fuel sources over time.
Yeah, and I'll add to that I'm not sure what every piece of the value chain will be providing and for how much. I do like Tina's answer on everyone will make some money until the last person enters, right? That's economic theory. The last person that enters will not make any. But I will say the value chain as we know it today in aviation is not going to be the same. It's not going to be FBOs, MROs making money on a lot of maintenance and fuel on margins on fuel. That's going to be gone because maintenance is going to be very little and electricity is so cheap. What margin are you going to make on an hour-and-a-half flight that requires only $24 in electricity? What margin are you going to make? 2 cents? So from that perspective, the model as we know it is going to change. The propulsion model of I'm going to sell you an engine at cost, if not below, but then I'm going to make all my money on services and parts to you, that changes. There are no services and parts. And so from that perspective, the value chain as we know it is going to change, and people will either adapt to it or lose out.
Okay, it's interesting. The next question, it touches on some of the things you mentioned there, Roy. How do you calculate the maintenance reserves for an electric aircraft? What does the number include, and how might it change with the technical evolution of batteries and motors?
Yeah, it's an interesting conversation. We're in those debates or in those kind of calculation discussions now. There's one moving part in our electric motor, one, and it's frictionless. It's magnets and coils. And so I'll say as near frictionless as you can do it. And so there's no wear and tear. There's no need for lubrication. There's no need to change lubrication because it doesn't exist. So all these elements of, you know, there's no explosions happening inside the engine. There's no, the temperatures that we're talking about are 80 degrees Celsius, 70 degrees Celsius, right? We're not talking about hundreds and thousands of degrees surrounding these parts. And so the maintenance will be, are the cables and wires still all connected? Is everything, you know, still in its place? And that's probably about it, unless something happens, some sort of fault, a short circuit, etc. And then you'll have some maintenance there, but even that, we've designed at least to be very modular and very easy to do. And so the way we're calculating it now is, what does it take? We're looking, first of all, at our cousins in automobiles and learning a lot from that, but then also playing with our own motors and taking them to stress limits that they haven't been, that they're not going to be operated in real life, but just taking them to those levels to see what it does. And so far, I have to say, it doesn't do much in terms of what it does to the propulsion system itself. So but on the flip side, though, we do expect that the regulatory authorities to begin with won't say, okay, zero maintenance, like we have on cars. They're probably going to have something just because of conservatism, and that's okay. So they'll probably say, hey, every X thousand hours, at least check that everything's still in place. Every Y hours, at least check that all the cables are in place. And then as hundreds and thousands of these propulsion systems and aircraft are flying around, data will tell us that we can start relaxing that even more. Right now, our expectation is at least 50% less maintenance to begin with. That's our expectation now.
Okay. Next question. 70% cost reduction is taking into account battery cycle life and replacement cost as well. To put things into perspective, our aircraft have a total operating cost per hour that is lower than the instructor's hourly wage. So
that's my answer to a question.
Sorry?
That is my answer to a previous question.
Oh, I beg your pardon. Tina, you're catching me out here. Okay, let me go further down. All right, here we have another question. Can a hydrogen fuel cell supply sufficient energy to take off, fly a representative distance to destination, and conduct 2 or more missed approaches due to, say, weather at the primary destination before diverting to an alternate, and then fly for a period equivalent to the current minimum reserve? Oh, that's
Yes,
I mean, it's quite a loaded question, but I mean, I can obviously see what you're getting at. I mean, of course, in all of our calculations, we've built in a significant buffer. So it's never just kind of A to B and that's it. You're going to crash if there's any kind of issue. So yeah, when we looked at fuel burn and sort of the energy required, we absolutely did it by industry standard, taking significant buffer into account.
And that's the thing, right? To anyone asking these questions, what happens if you run out of batteries? It's like, come on, there are clear regulatory standards on what's required of an aircraft, its ability to divert, the reserve that's required. None of that's going to be relaxed, and none of it's expected to be relaxed because we're going electric, be it battery or hydrogen. That's all going to be exactly the same. Why doesn't anyone ask? Yeah, why doesn't anyone ask the question? Hey, what happens if you run out of fuel? Well, then 1, you're an idiot, and 2, you glide to safety. Same thing. Run out of batteries, run out of hydrogen, glide to safety, right? Those standards, the beauty of aviation versus automobiles, etc. All those standards are very rigidly in place. We don't have a choice to say, oh, let's go with batteries without reserve. It doesn't happen.
So let me just put in perspective. Our notional design for the hydrogen-powered mini liner is actually only refueled once per night. And it does 4 to 6 commercial hops during the day. So it actually has way more range than what a comparable jet fuel-driven aircraft would have. Mind you, just for another perspective, hydrogen as a fuel is about 3 times as dense as jet fuel, and you can utilize usually between 20 and 40% more of this energy while you are converting it to motive force for this class of aircraft. So hydrogen will go a long way, provided the aircraft can fit the hydrogen tank. It's not a mass issue, it's a volumetric issue in how your aircraft will look like. But they go a long way.
Tine, I've been reading ahead now and I see you've been answering all these questions. You're ahead of us here. So does anybody have a question that has not been answered yet in the audience? Apparently not. All right, Ernie, back to you.
I think there's a couple of questions here, although that may be the analysis on the, while 60% to 80% cost reduction is great, has anyone seen a real world analysis of an existing airline's X% potential revenue increase given the new routes they could capture? So has anyone taken a deep look at that?
I can answer it. The 2016 NASA study with Georgia Tech, the thin hole study, actually jump-started many companies. And I would kind of like to think that from this wave, also ZeroAvia was launched because it was a clear indication that by going electric, especially on this thin haul routes, so small airport to small airport, or feeding passengers from rural to bigger hubs, has substantial gains when it comes to profitability and the size of the market. And there's been many more since. I would like to think that every startup who's pitching for capital has their own exponential growth story, but there are many studies which are third party and independent that are basically in a 1 per year resolution, the high quality ones. I've noted some in the chat response. So yeah, it's not a caveat, it's actually out there, and somebody will fill this space. It's not a matter of if, it's a matter of when.
Okay. Generally,
also, maybe just like Roei pointed this earlier, that there's, you know, the fact that there already are new companies being set up to address this, I think is also just a very good indicator, because I think it's not just more revenues for the existing airlines that can fly more routes. I think it's a new opportunity to travel differently. And the fact that there already are some early signals of that by new startups that are focusing on this kind of point-to-point commuter travel, I think is a good just commercial sort of symptom of the fact that this is going that way.
Yeah, you can look at in LA, for example, the LA area alone, there are 4 different companies now, pre-COVID, right, that were offering commuter flights. One of them, just to notice, to note, Float, F-L-O-A-T, fly over LA traffic, something like that. They were using Cessna Grand Caravans, and they were charging $39 to $45 per flight. $39 to $49 per flight of, it was like 15 to 25 minutes. Imagine that caravan not costing $400 per flight of fuel, but $24. They can either keep charging $39, which is super cheap, and then make more money, so offer more flights, or charge $10 per flight. So imagine what that does to the economics of a business thinking about, could I really afford this? Imagine what that does when you talk about commuting. You know, I'm not going to pay $150 to go over LA traffic, but $39 starts to be interesting. $29 starts to be a compelling, how can you not do that to save traffic? And so these are models that are flying today, $39, look them up, float. And so this is a real business changer that's happening because the demand exists. Up until now, the supply was just impossible. The beauty is the supply now is starting to exist as well.
With smaller companies doing much of the disruptive innovation in this industry, what would your advice be to the existing major players? Do they need to come to you guys to adapt? What should they do for innovation?
My advice would be, don't do anything. Keep not innovating. Don't do anything new. All is well.
All right. With that, I think we'll leave for our final solution. And it's time for our commercial. How can AirInsight help you? We provide strategy, risk mitigation, market research, competitive intelligence, independent forecasting, and a number of data models and analyses that you can see on our website. So we tend to be a boutique consultancy with added value, and we invite you to contact us if you're interested in and have some issues that you'd like to look at. Our next webinar is coming up in 2 weeks, August 18th, and it'll be about Embraer. We'll have our team, myself, Michelle Merlizo, and Addison, doing our webinar on the 18th, and we'll talk about some of both the business and commercial trends at Embraer. So that's basically a wrap. We'd like to thank our panelists for a great performance today. Thank all of our audience members for being with us, and we look forward to seeing you in a couple of weeks.
Thanks, everybody.
Thank you very much.
Thank you.
Thank you.
Bye.
Thanks. Bye-bye.